Okay, guys, so the beauty about this video is that we could jump right into solving by factoring because in order to do so, we would have had to learn how to factor. And I hope by now you've kind of familiarized yourself with factoring and the different types of problems that you see factoring. So here we have a couple of equations. Of course, we can't solve unless we're working with equations. Prior, we were working with expressions, so we were just asked to factor those expressions. Now we're asking to solve by factoring. Now, how you know you have to solve by factoring is that usually one of the highest powers of your variable is going to be the power of 2. You're going to be having like second degree polynomials. And if that sounds strange to you, I have a video on what are polynomials so you'll understand what's a second degree polynomial. Also, it's important to know that in order to solve by factoring, your equation must equal 0. So for example, if you have an equation like this, 4x squared minus 37x equal negative 9, you would have to transpose that negative 9 by using the opposite term, positive 9, to both sides to cancel on one side and to add to the other side so it can equal 0. So again, your equation must equal 0, and before you can finish solving a problem after you factor, remember factor is converting terms into factors. So after you finish factoring and you have it set up in factored form, then you will solve for each x. So what you'll do, you'll take each factor, set it equal to 0, and you'll get x. So let's start with the first one. So the good news about the first equation is that it's already in factored form. All right. So this is x minus 6 times x plus 5 equals 0. So once your equation is in factored form, you set each factor equal to 0 and solve. You set each factor equal to 0 and solve. All right? So here, this is a factor. Now you got to make it a term. So you'll have to break this up by dropping the parentheses because there's nothing there to work out inside the parentheses in case you're thinking about order of operation. So this is now x minus 6 equals 0. We can see that the term negative 6 is affecting x from being by itself. So we'll perform the opposite operation to both sides. What you do on one side, you must do to the other side. So x is 6. We'll perform the same action over here where the quantity x plus 5 is now x plus 5 equals 0. Subtract 5 from both sides using the concept of opposite operation, and x is negative 5. So now we can say for this equation, x is 6 and negative 5. All right, so this is an equation that's already in factored form, equals 0, so we did not have to factor it. We just have to set each factor equal to 0 and solve. Now let's look at another equation, right? A second degree equation. We have here x squared minus 7x equals 0. Now, as you can see, this is only two terms, but those two terms are actually factorable, right? You don't have to bring over the 0. That won't make any sense because it'll just be 7x squared minus 7x plus or minus 0, which is still the same thing. It's also not a difference of two squares because even though it's two terms, right? And it's a difference, you can't find the square root of both terms. But if you look at it, it has a GCF of x. So I can factor out the x, and I'm left with x minus 7 equals 0. So now this equation, this side of the equation, is in factored form. So now I'll set each factor equal to 0. So x equals 0, and x minus 7 equals 0. So x is already 0, as we can see in this case. And here, we would add x to both sides, as in the rules of solving. So we have x is equal to 0 and 7. And if you want to know if your solution is correct, just try substituting the value of x back into the original equation. See, if I substitute 0 into x, I'll get 0. 0 equals 0. And if I substitute 7 with x, I'll get 49 minus 7 times 7, which is 49. 49 minus 49 is 0. And that's one way to test to see if your x values are correct. Now let's do another expression. Let's do another equation. Let's do a difference of square. Here we have a difference of square. We have x squared minus 4 equal to 0. How do we know it's a difference of square? We factor by difference of square. Here we have two terms, right? Difference of two squares, I should say. We have two terms. It's a difference. And I can find the square root of x squared and 4. The square root of x squared is actually x, and the square root of 4 is actually 2, right? Remember the difference of square formula that says a squared minus b squared is the same as saying a plus b times a minus b. So here my a, I have my b, so that's x plus 2 times x minus 2 equal to 0. So now I'll set both my factors equal to 0 and solve. So x plus 2 equals 0. X minus 2 equals 0. And it's obvious here, these are simple equations. The opposite would be a minus on both sides. So x is minus 2. And the opposite would be a plus on both sides. So x is plus 2. So x is plus and minus 2. All right. So that's one. So we have an example where it's in factored form. We have an example where it's just two terms and you can still factor it. We have an example where we can use the difference of square to factor and then solve. And if you notice, they all have in common, the equation must originally equal to 0. Let's try another one. All right. So here we have x squared plus 14x plus 48 equals 0. Now, what's beautiful about this equation? Yes, the leading coefficient is 1. So if I could just find factors of 48, of positive 48, that when I add, I get positive 14. That looks like 6 and 8. Yep. So I can just go straight into writing my factored form. All right. If you look at the video of factoring trinomials, part 3, it'll show you where this concept came about. Or like I said, by now you should have understand how to factor different types of problems. So now I'm going to set each factor equal to 0 and solve. So this is x plus 6 equal to 0 minus 6 minus 6. So x is negative 6. And there I'm going to subtract 8 from both sides. So x is minus 8. So x is negative 6 and negative 8. All right. And I'm almost certain that if we plug these back in, substitute these values back into the original equation, we will get 0. All right, so let's do one more for the road. Let's see what it looks like if we do a problem like 4x squared plus 19x minus 5 equal to 0. Okay, so here we don't have a leading coefficient of 1. So we're actually going to have to use our AC method, or the method where we have to find the product of the first and the last term to equal the middle. So we actually have to take this trinomial and make it into 4 terms and then factor by grouping. So let's see what we have. So this is actually 4x squared times negative 5, which will actually give you negative 20x squared. So here we have a negative product. That means it has to be a positive and a negative factor in order for us to make it equal the middle term. So that also means that we have to subtract to get our middle term. Okay, and like I said, this is in depth in previous videos on factoring trinomial. Actually, the first video on factoring trinomial. So here it looks obviously that it's going to be 20 and 1. Right, 20 and 1, because if we subtract 20 and 1, we'll get 19. But in order for us to know which factor takes the signs, the positive and negative signs respectively, we let our middle term gauges that the larger factor takes the sign of the middle. So the larger, because it's positive, the larger factor, which is 20 or 20x, and this is 1x, will take the sign of the middle. That's because when we subtract, we have to keep the sign of the greater magnitude. Okay, so Now I'm going to write my trinomial into 4 terms as 20x minus 1x minus 5 equals 0. I'm going to factor by grouping. All right, this is all news to you now. 1x plus 5 equals 0. Then factor each group individually. Right, so this is 4x, and we're left with x plus 5. The GCF for something that we can't factor is usually 1. So we're left with x plus 5. And then we'll see that these are the same. So now it's x plus 5 times 4x minus 1 equal to 0. And now we have our equation expressed in factored form. Now we're going to set each factor equal to 0 and solve for x. So here is nice, easy peasy. X is equal to -5. And here we just have to make an extra step because we have a term and a factor affecting x from being by itself. So we usually do the inverse order of operation by getting rid of our terms first. So we're going to add 1 to both sides. And then we're going to divide. Remember, we're doing opposite operation, 4 to both sides. So in this case, the two values of x is -5 1/4. And if you have time, just substitute it back into your original equation, and you'll see that your answer will be 0. All right, guys, if you have any questions with regards to solve by factoring, please feel free to reach out to me. You know how to. All right, have a good evening or day whenever you watch this.